So today we will discuss about the Le-Chateliers principle. The basic purpose of this principle is basically to increase the production of the product. What is the purpose? Basically to increase the production. Is the basic purpose of this Le-Chateliers principle. Well, consider we have a reaction, for example A plus B, and they all are in equilibrium, produces 2C plus D. So basically this reaction is at the equilibrium, right? Okay, when they are on equilibrium, it means that the rate of forward reaction is equal to rate of backward reaction, and the concentration of the reactant and the concentration of the product both are constant, right? And which type of reaction it is? It is basically the reversible reaction. It is a reversible reaction and the concentration is constant, right? Okay, now basically equilibrium is a state where all the things are basically stable. And the reaction basically tends to achieve the equilibrium. Like every reaction wants to achieve the equilibrium state. Basically the reversible reaction wants to achieve the equilibrium state. Now basically what is the statement of this Le-Chateliers principle? Okay, according to the Le-Chateliers principle, if stress is applied on the reaction, now the stress can be of any form. If we increase, for example, increase in, or you can say basically decrease. So basically we can write here change in concentration, pressure, temperature, or catalyst. If we apply a stress on the reaction, this stress can be in any form by changing the concentration, by changing pressure, temperature, or catalyst. The equilibrium gets disturbed. By applying the stress, the equilibrium gets, what will happen? This equilibrium gets disturbed. So basically what will happen? This equilibrium wants to acquire its same equilibrium. The changed equilibrium wants to acquire the same equilibrium state by changing the direction for a few moments. Now what will happen? Actually the equilibrium will try to undo the change, right? So what we have here, equilibrium gets disturbed, so that this disturbed equilibrium wants to basically undo the change, by shifting the reaction towards a direction, the direction of reaction, right? Now what is basically what is the statement of Le-Chateliers principle? That if any kind of stress is applied on a reaction, this stress can be in any form by changing the concentration, by changing pressure, or changing catalyst or temperature. The equilibrium gets disturbed. Like if, for example, it is quite obvious that if you will change the concentration, the equilibrium will get disturbed. So the equilibrium tries to basically maintain its equilibrium. Like the disturbed equilibrium tries to maintain the original position by changing the direction of the reaction. So this is basically the main statement of the Le-Chateliers principle, right? So now let's first discuss that what happens if the concentration is changed. right? If there is change in concentration, right? Consider that we have a reaction which is basically N2 plus 3H2 and they are in equilibrium, which is NH3, right? This is the reaction. Okay, if I want to, like, if I have increased the concentration of nitrogen, so this is the change, right? This is what I have changed. Now what will we undo? That concentration of the nitrogen will be decreased, that is undo. So for that purpose, like if I increase the concentration of the reactant, the product will also increase. So basically what will happen, in order to decrease the concentration, the direction of the reaction will move towards the forward. So direction, equilibrium shift, forward direction, equilibrium shift forward, right? Equilibrium shift to the forward reaction. Okay, what if I decrease the concentration of this? If I decrease the concentration of the nitrogen, like this is my change. Now what will happen, what will undo? The concentration of the nitrogen will be increased, that will be undo. Now how it will happen? By changing the direction of the reaction towards the left side, or you can say by equilibrium shift towards the backward direction. So backward reaction, right? What if I remove the amount of NH3? Like the amount of NH3 is removed, right? If I remove the NH3 amount, obviously the back of what will be the undo? That to increase the NH3 amount. So what will happen, basically the forward reaction will be increased. The forward reaction will be increased, right? So now let's consider one more example of the contact process. For example, we have SO2 plus oxygen, and they will basically it will produce 2SO3, and here we have 2. Now if I want to basically increase the production of SO3, I want to increase SO3. What should I do? Two things I can do in order to increase the production of SO3 is, first, I can increase the reactants. Either I can increase SO2, I can increase SO2, or I can increase O2, so that the reaction will turn to the forward. Or either I can basically remove SO3, so the reaction can be turned into forward direction. This is how I can basically increase the production of SO3. Basically in when we basically remove the reactant, or when we decrease the reactant, right? So what happens is the QC becomes lower than the KC when the reactant is basically increased. For example, here I said, in order to increase the SO3 production, I will increase the reactant. So when reactant is basically increased, the QC becomes lower than the KC, right? the QC become lower than the KC when the reactant is increased, right? So I hope this is clear till here. If you have any kind of queries, you can ask me in the comment section. We're very glad to answer you guys. So in my next video, I'll be continuing the effect, like the change in pressure and the change in temperature.